assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Want to find the frequency of the oscillations, but first we want to find the effective spring constant. The effective spring constant is found by the force divided by delta x. However, we can say that the left-hand spring is elongated by, we can say, left-hand spring. We can say this is elongated delta x sub L, so for left. And then it has, the left-hand spring also exerts a force of magnitude, so we can say force of magnitude that is equal to the spring constant multiplied by the change in the displacement of the left-hand spring. For the right-hand spring, it's the exact same. We're going to say it's elongated, again, delta x sub r this time for right. And then it exerts a force of magnitude equaling k times delta x sub r. Now, due to Newton's third law, these elongations must be equal. So we know that due to Newton's third law, we can say that delta x sub L is going to be equal to delta x sub R. And if that's the case, this means the two elongations must be, the total elongation is twice the elongation of either spring. So we can say that delta x is going to be equal to the total elongation would be 2 times x sub L, or 2 times delta x sub R. Either one, we can use either one. However, now the left hand, we can essentially say that now the effective spring constant is going to be equal to k times delta x sub L, knowing that the left-hand spring exerts a force on the block, and this would be its magnitude, but this would be divided by 2 times delta x sub L. And so this is going to be simply equal to the spring constant given in the problem divided by 2. And so when we want to find the frequency of motion, we have to plug in the effective spring constant. So the frequency of motion would be equal to, the frequency of the oscillations essentially would be 1 over 2 pi multiplied by the square root of the effective spring constant divided by the mass m. This would be equal to 1 over 2 pi multiplied by the spring constant of either spring divided by 2m, and we can then solve. So this would be equal to 1 over 2 pi multiplied by k. We know k is going to be 6,430 newtons per meter, and then this would be divided by 2 times the mass of 0.245 kilograms. And we find that the frequency of oscillations is going to be 18.2 hertz. This would be our frequency. This would be our final answer. That is the end of the solution. Thank you for watching.